to Module 14.3. In this lecture video, I'm going to show you how to find what we so-called the equivalent rational expression. So this is something we done back in Module 2 when right before we learned how to add and subtract fractions. So basically it worked like this. If I would say, here I have a 4 over 5, that is equal to, let's pretend the least common denominator is 35, and with a question mark here. So the 5 is the original denominator. Let's say 35 is the new LCD. So for 5 to become 35, we got to times by 7. Or sometimes we say 5 will go into 35 7 times. So now my numerator will also multiply by the same number to become this new question mark, which is 28. So what we're saying here is 4 over 5 is equivalent of, if we say the LCD is 35, then its equivalent numerator got to be 28. Okay, that's called finding equivalent fraction. So we're going to do pretty much exactly the same thing, just using polynomials. But I'm going to demonstrate this slightly different, okay? I'm going to demonstrate this slightly different. As a matter of fact, I'm going to rewrite some of these problems. Let's pretend, okay, 4 over 5 times x minus 7 was my original denominator. And now my LCD, let's say my least common denominator, is 20 times x minus 7 times x plus 7. Okay. So let's take a look. Okay, I'm going to just move this slightly over. So remember now, down here is the LCD. Okay. Up here is my original denominator. So mathematically, what we are saying is, just like up here, 5 will go into 35 how many times? If we say the same thing here, that means 5 times x minus 7 will go into 20 times x minus 7, x plus 7 how many times? Mathematically, that's actually how we say it. This is what it looked like. So basically now it's become reducing a fraction. As a matter of fact, 5 times x minus 7 will go into my LCD how many times? Will go into 4 times x plus 7 times. Will go into as 4 times x plus 7 times. That means my numerator, it was 4. Now we'll need to multiply 4 times x plus 7 times, okay? Because the denominator will need to multiply that same amount of time to become here, so the numerator will do the same thing. So this question mark will just be 4 times x plus 7, which we can say this is 16 times x plus 7, or we can multiply this out. But for right now, I think write them as a factor form will be okay. All right. So that's the answer up here, 16 times x plus 7, or if the homework wants you to multiply this out, you can multiply them out as well. All right. Now, I'm going to show you how to do this, okay? Show you how to do this very differently. Because here I wrote it as the way how we normally would have say it, and this is what it looked like. But rather than do this, write this big old thing every time, there's another way we can actually say it, which is still doing the same thing. So basically, again, let's pretend this is my LCD, okay? Pretend that's my LCD. So let's factor. Normally to find, before we can even find LCD, let's pretend that's an LCD. Before we can even find LCD, we got to factor our denominator. So 6y squared minus 13y minus 15. If I will factor this denominator, I can use 15 is 3 and 5. If I use 6y and y, 3 and 5. I cannot put 3 with a 6y. That costs me a greatest common factor I don't have. So 3 here, 5 here. Outer is 18, inner is 5. Since the last sign is negative, the choice for the sign is 1 positive, 1 negative. Since I need to end up with negative 13, right? 18 and 5 combined is 13. I just need to do it by subtraction because the last sign tells me how to get to the middle term. Since the middle term is negative 13, I need to give the negative to the greater of the two inner and outer. So I need to have a negative 18 on the outer. This is positive. All right. So once my first denominator factored out, is look like this. Remember, I have an LCD right here, which is 6y plus 5 times y minus 3 times 6y minus 3, right? So that's my LCD. So basically, if you just look at them, my original denominator in factor form is up here. Will go into the LCD how many times? So that means I can write 6y plus 5 6y plus 5 times y minus 3 down here will go into my LCD, put up here how many times, then I can cancel them out. So rather than write it like that, all I need you to do is do a little bit of comparison. What does the LCD has that my first denominator do not have? What does the LCD has down here in red that my first denominator do not have? My first denominator do not have who? The 6y minus 3. And that will be how much I will need to multiply. So basically, this question mark now will be the y plus 6 is still there. The y plus 6 on the original numerator is still there. Need to multiply, increase how many times? Well, the denominator is missing the 6y minus 3. So that means we will need to multiply 6y minus 3 top and bottom to get to the question mark. So what does the LCD has that the first denominator do not have? It is missing a 6y minus 3, so that's what I need to multiply in order to reach the question mark. Okay, so what does that mean, missing 6y plus 3? Because the original denominator 6y plus 5 times y minus 3 will go into the LCD, right? Will go into the LCD how many times? Well, if the original denominator has the same factor as the LCD, in this form they will all cancel out. So that means my original denominator don't have the 6y minus 3. So that means my denominator will go into LCD 6y minus 3 times. Oop, I didn't mean to say plus, it's minus 3 times. So if I need to go into it that many times, 6y minus 3 times, then my numerator will multiply the same factor, top and bottom. All right. So you can just write them as a factor form for right now. In another section, I will show you how to multiply all this out. When we come to add and subtract. All righty. So real quick, what does my LCD has that my first denominator do not have? So I'm going to pretend y squared plus 9 cannot be factored other than 1. So I'm going to put them in the parentheses. Write them as like a factor form, right? So what does my LCD has that my first denominator do not have? My first denominator do not have the y minus 7. So that means my denominator will go into this LCD, y minus 7 times. So whatever is missing, that's what my numerator will multiply. So my question mark got to be y plus 7, the original numerator, times the what's missing, which is y minus 7. All right, quick question. Why do I put, I know I put the y minus 7 in the parenthesis, but why do I have to put y plus 7 in the parenthesis? What happens if I don't? It will look something like this, which means this is actually two different terms. So only the 7 will do a distribution, but not the y. So that's actually incorrect way of writing it. So why do I put y plus 7 in the parenthesis? Because it's two terms representing one numerator up here. So whenever I have multiple terms representing one thing, I always put them in the parenthesis, because it's both of these terms got to multiply what? The y minus 7. So if we don't write them in the parenthesis, no, sometimes we just distribute with a 7, not with the y. Okay? So the question mark is going to be this answer in factor form. So in the next couple of videos, I will show you how to add and subtract rational expression. So we will use the same technique. Okay, what does the LCD has that my denominator don't have, and that's how many times I will need to increase. All right, that will conclude this lecture video. Thank you for watching.